Yeah, hey everyone. So Matt Hartman here, and today I'll be talking about some new Apigee X networking architecture changes that are now supported. So specifically private DNS peering when VPC peering is not enabled. So we'll take a more holistic view to start this video, talk through the different options to communicate to and through your Apigee instance. We'll talk about the value out of this functionality here. And from there, we'll go through an exercise where we enable everything that you can see in this architecture diagram, be able to achieve VPC, so achieve DNS peering where VPC peering is not enabled. So with that, first things first is I wanted to talk through different ways to communicate to your Apigee instance. The first way is VPC peering. So VPC peering basically says on installation of your organization, take a /22 CIDR address and a /28 CIDR address, so the /22 to communicate to your Apigee runtime, /28 for support, so that your specific consumer projects, your customer project, is able to perform any pertinent commands through your Apigee X SaaS runtime Google Cloud project. So pros and cons to that, obviously via VPC peering. One of the biggest cons we specifically see is the fact that for more complicated network patterns and architectures, makes it a little bit difficult twofold. So the first fold is opening up a /22 CIDR address range might be difficult because there might not be a /22 address range to be able to peer to the Apigee instance runtime. Second item is supportability, just given the fact that there's not a specific IP address associated to the runtime, rather it's that peering range. So it makes it a little bit more difficult from identification, supportability, everything along those lines. So with that, we have a second option where we don't use VPC peering, and we use private service connect. So private connectivity and that service-oriented architecture to be able to communicate to and through your Apigee X instance. So what I'm getting at with that is your SaaS runtime is available via a private IP address that is addressable to any projects that you allow list within your runtime configuration. Much easier, much more scalable, just has a lot of the networking to shift down through configuration objects via PSC. So typically a more preferred approach. However, one of the limitations of this functionality previously was the fact that you cannot orchestrate DNS peering with this architecture. So what I'm getting at with that is, as you can see on my screen here, I'm in the Apigee Blade. I have an Apigee X proxy created here, which, as you can see, I'm communicating to an HTTP bin proxy. That's basically a virtual representation via Private Service Connect. So I have an endpoint attachment, which you'll see in a second. And with that, I have to address that endpoint attachment via its IP address. So makes it a little bit more difficult from a troubleshooting supportability perspective. Again, just considering the fact that this isn't like my internal.api.com or my gkecluster.internal.com or whatever it may be. You have to perform additional lookups to identify what this target service is, which again, like I mentioned before, is just the service I created here. And I'm addressing it via its host, but not via DNS. So with that, let's go through how we can mitigate those concerns via this new networking construct. So with that, we have this new concept, which we'll go through, called a peering domain. So when the Apigee X instance sees a domain that isn't something available via the internet, it looks at these private DNS zones. So for example, foo.com or bar.com across different projects. So it says, okay, I see foo.com. I see that this foo.com private DNS was peered to my runtime. I know what project it's in, it does a lookup, finds the private IP address, and is able to address that service accordingly. So pretty self-explanatory, kind of how you'd expect this to operate. And with that, let's get right into it and test some of this functionality. So I'm going to be going through the documentation here. If anything needs to be supplemented, whatever it is, I will provide that in the article, or I'll be using the UI so you can follow along. So before I get into verifying whether VPC peering is not enabled, I would like to make sure that I have the DNS API available to my specific service. If not, it's as simple as going to Cloud DNS and basically going through the wizard to enable the APIs. But there's a very easy gcloud command to be able to orchestrate that. So it's gcloud services enable, that's for enablement, so gcloud services list, and then I'll say the project equals the project ID, so my Hartman sandbox, as you can see there. And then I'll look for dns.googleapis.com. So with that, give it a second, and as you can see, it is available here. Great news. Second item for verification is I'm going to run this command that you see here to basically say, is VPC VPC peering not enabled. So what I will do is I will take this and I will say from there, let's grep disable VPC peering. Should be set to true. Capitalization matters here, so great, got that right. So as you can see, it is set to true. Great. So I have enough. I have the prerequisites set up so that I should be good to go. First item with that is we need to get the project number. So we'll just say take this gcloud command here to describe this. So here's my project ID. Given just this information, so have all that information. So Hartman Sandbox is my ID. Project number is this, and the reason we need that is for the second command you see here. So we're adding an IAM policy binding for the per project service account. So if you're not familiar with what this service account is it's basically a service account that is a virtual representation of your Apigee X instance. That Apigee X instance, for whatever reason, so for this use case for DNS peering, is able to communicate to and through your project. So with that, I'm going to copy paste this command. Producer project ID is my project ID again. Service account is service dash and then my project number, which we created there. So we identified that via the gcloud command. I'm going to copy paste this, and that's going to provide the IAM policy binding so that my Apigee X instance can peer with my service. So should be good to go. Created that role there for me, which is great. From there, before we create a DNS peering zone, which allows, again, that communication to and through, what I'm going to do is I'm going to create a private DNS zone in real time here. So what I will do is I'll go to the cloud DNS. I'll create a zone. My zone is going to be a private zone like we talked about before. I'll just call it Hartman POC. DS name, I'll just call it hartman.com. It's private. I will peer it to my network, which we'll use again in a second. So this is the network I'm going to be using. So it's extractable and exposable via this service. So once I create this, as you can see, I have my DNS records kind of just pre-propagated, and I have the information I need to be able to proceed further. So the DNS name there, as you can see, is all set up, which is great news. So now that I have that set up, what I will do now is I will create, so I have a DNS peering zone, I have all that information about to create. Now I will create an A record. So I'll create a record that's going to represent that service that we talked about before. So like I mentioned, I have my HTTP bin service. So I'm going to go into Apigee. Just give me 1 second. I'm going to now create a record for my endpoint attachment because I don't want to address it via this little private IP address. So what I will do is I will go to Cloud DNS settings here, and I will go into my Hartman POC. I will add a record set, so I will add an A record. TTL of 5 minutes is fine. Here's my IP address, and I will call it foo. So it matches what we had before. So foo.hartman.com. So pretty self-explanatory what I'm doing there, just creating a record, TTL of 5 minutes. I'll create that. So as you can see, I now have foo.hartman.com enabled for this workflow representative of the IP address that I mentioned before. So now with that, what I'm going to do is I'm going to create a peering zone. So again, so that my Apigee X instance can communicate to this specific runtime. So I have hartman.com. I have my sandbox. I have Hartman POC as the DNS zone ID, which is great. Project ID, Hartman Sandbox. That's my VPC that we talked about before. It's going to run a long-running operation, which you'll see in a second. In progress, I can now check to see if this is accepted. So my DNS zone again, Hartman POC. And from there, let's see what happens. Active. Great. So now what I can do, because I peered that DNS zone, is I can go into Apigee, and I can now go to my service, which I can now redeploy with that DNS entry. So what I'm going to do is I'm going to go to my target endpoint. I named it, so here we go. I'll call it foo.hartman.com:80/get. That was the service I used previously. Now I have, again, foo.hartman.com:80 because I exposed my service on HTTP. I'm going to save that. I'm going to deploy it in a second as well. So put that there. And now what you will see, and again, DNS propagation takes like a couple minutes for it to be able to orchestrate. So again, I will just allow this to deploy. I will take a second, and then I will issue some sample curl commands against this runtime. So I'll do curl, I'll do the browser, and just kind of showcase this workflow working to expectation. Because again, all I'm doing behind the scenes, I'm just calling the HTTP bin service. So revision 8 looks like it was deployed. So what I will do is I'm going to take the information I need to be able to make this request. So my test environment is mapped to this. So I'll call it HTTPS / and then I will grab the resource path. Great. So I'm going to grab that now, which should be in the default proxy endpoint route. So it's /get. Because again, what I'm doing is I'm calling the Apigee proxy. I'm now able to communicate through my service attachment via this foo.hartman.com that I created on port 80, and it should work. So I'm just going to pause this for a minute, allow DNS to propagate, and I will run this command in a second. Cool. And now, as you can see here, my DNS should have propagated. I'm going to call into my service, and everything is working to expectation. As you can see, my URL is propagated, foo.hartman.com/get. So everything working to expectation, which is great news. So thank you, everyone. Hope you have a nice rest of your day. And yeah, appreciate it. Bye.